Hi everybody, today we're all about the bling, as long as it's got crystals, because we're about crystals because most crystals are ionic compounds. Whether they're crystals in your grill or this is some of my personal bling, and I can tell you these are not diamonds. And diamonds are not ionic compounds, but these crystals are. And then we see them in nature too. Just in rocks, you'll see crystals all around. Not to mention, we put them on our food. Here's sodium chloride, table salt. They're crystals. Uh, Objective. Positively charged cations combine with negatively charged anions to make ionic compounds. And what are ionic compounds? They're crystals. Okay, and here's another look at it, just so you can visualize. This is table salt under a microscope, and if you were to go even further to see the ions, all these purple ones are sodium ions, green is chlorine ions, and you can see there's a pattern there. Here's another image, and here's one more, slightly different, but it's the same idea. You have a repeating pattern of these ions that make solids. So there are some notes. Here's the essential question. So how do ionic compounds form? How do we name them? Write the formula. And so if you were in class, you've already got notes like this. If you weren't, hit pause and write these out. And I'll tell you right now, ionic compounds, here's the definition one more time. Cations have a plus charge. They attract anions with a negative charge, and they make solids, crystals. Why do they attract? They're like magnets. They are not magnets, but they act like them. Positive and negative go together. Opposites attract. Okay? So here we go. First, a little review. I've got 4 elements here: sodium, magnesium, oxygen, and chlorine. And this is what they become when they become an ion. And so why is sodium a +1 ion, or have a +1 charge? Well, you could say I've got my periodic table, and that whole family is +1. There's sodium. Here's magnesium, +2. Oxygen, 2-, chlorine, 1-. That's one way to figure it out. But why does the periodic table work that way? You have to remember, elements, the atoms want full shells of electrons, that outside shell. And if it's not quite full, the atom gains electrons to fill it up. Then it's stable. Okay? And if you're gaining electrons, remember, electrons are a negatively charged particle. If you gain those, you have more negatives, you become a negatively charged anion. Or if you're like sodium, you give electrons away, and then the shell right below it is already full. But if you lose those negative charges, it leaves you positive. So look at the numbers here. Here's sodium. It's atomic number 11, 11 protons, 11 electrons. 11 pluses, 11 minuses equals 0, no charge, but it's not stable. And so it loses 1 electron, and now it still has 11 protons, 11 pluses. Now it has 10 electrons, 10 minuses, and if you add those together, it equals +1. That's where the +1 comes from. For oxygen, it has atomic number 8, so 8 protons, 8 electrons, but it's not stable. It gains 2 more valence electrons to fill out the shell. Now it's got 8 protons and 10 electrons. Do the math. It gained electrons, which makes it have a 2- charge. It's a little counterintuitive, but that's important to understand. Okay, so that explains where we got those charges. So now what happens? Now you got all these positive charged ions and negative charged ions, and they attract to each other. And so in class, this is the way we did it, to give you a visual on how they go together. And so they can all, positive and negative can join, just like the ionic dating game. And so if you have sodium, here's my sodium, what can it join with? Well, it can't join with magnesium. Positive and positive repel, but it can join with chlorine, Na 1 plus, chlorine 1 minus. The size of this box shows it's just 1 plus and 1 minus. If it's 1 to 1, it's the easiest. It balances out. And we just write NaCl. Oops, that's supposed to say sodium chloride. And that's what it looks like, a white powder. Crystal, white crystal. Sodium can also react with oxygen, but oxygen's got 2 minus charges. And so in order to balance that out, since sodium only has +1, you need 2 of those. So I've got 2 sodium ions to my 1 oxygen. That's why down here I wrote Na2O. Notice I don't write any of the charges. Once I write the formula, I have to balance the charge and it goes away. It's also a white crystal. Magnesium can react with both of them too. Let's do magnesium chloride. Notice it's the other way now. Magnesium's got a 2 plus charge. It's got a bigger box. Chlorine's got a smaller one. And so to neutralize that charge, you need 2 chlorines. How do we write it? MgCl2, little 2. That says there's 2 chlorines to 1 magnesium. And then with magnesium oxide, magnesium's 2 plus, oxygen's 2 minus, and so they cancel each other out. It's 1 to 1, MgO. So naming them is not so hard. You've got magnesium, the cation always goes first. And then in class, you got a naming chart that looks like this, right? And so just notice the anions have special names. But there's chloride, there's oxide, and then there's all the ones you have. And then just to point this out, these are 2 anonymous students. You can't see their faces, but this is the lab we did. And so you can see not all ionic crystals are white. Here's blue and orange and brown, so it can be other colors too. But hopefully this gives you a visual on it. Okay? And really, that's all there is to it. The step 1 is to know that you are combining a cation and an anion. Cations are the metals, anions are the nonmetals. They're crystals, and then you got to balance those charges. Okay, maybe if we had aluminum, aluminum's got a 3 plus charge. We need 3 chlorines here because they have -1 each. And so you just have to figure out how many you need to balance the charge. And so I hope this was helpful. You're welcome to watch it again. Make sure you jot down the notes and write a nice summary. See if you can explain or answer these questions in your own words, and then write a couple questions in the margins. Okay, thanks everybody. See you next time. Make sure you fill out the Google form.